So, good evening, everyone. Good afternoon, everyone, and welcome to this lecture. This is our last lecture on simple harmonic motion, and in this lecture, we are going to finish this topic once and for all and probably start with waves. Let us see. I have sent you the sheets for SHM and waves and gravitation. Did you get it? Did you get the sheet that I have sent you or not? So, you got the sheets, no? That I sent you yesterday, day before yesterday?
No, sir.
Okay, I've already sent it to you. Must be on the way. You must be getting it. Anyways, let's begin today's class. In the last class, we had seen some cases of SHM, and I told you to remember those cases because any of those questions can come in SHM. We had seen the SHM of liquid in a tube, then we had seen the SHM of a floating cylinder, bar magnet, a ball rolling in a hemispherical bowl, then SHM of a gas, and all those things. I've given them as standard cases, and I hope that you can remember all of those cases. One case was for gravitation as well. In fact, two cases was for gravitation. And remember these two cases that we did, number 9 and number 10. In most of the cases that we have seen, what we have seen is that the motion remains SHM only when the distance x amplitude is small. In these two cases, case number 9 and case number 10, throughout the motion, the motion is simple harmonic throughout the diameter of the earth. So you don't have to throw it exactly at the center of earth to get SHM. These questions are only two questions where the motion remains simple harmonic no matter the distance being small or the distance being large. What we are going to do today, though, is known as superposition of SHM. What do you mean by superposition of SHM? Superposition of SHM. What do you mean by this superposition of SHM? Any idea?
No, sir.
Well, superposition of SHM means a particle may be executing SHM or two particles may be executing two different SHMs. And if we add those two SHMs, we call that as superposition of SHMs. So this superposition of SHM can be the addition of SHM of two particles, or it can be the addition of SHM of one particle. It may be executing two different SHMs in the same direction. It can also execute two different SHMs in two different directions. So the addition of SHM is known as your superposition of SHM. Now, if a particle is executing two SHMs, then the resulting motion is found by adding the two SHMs. This phenomena is known as your superposition of SHM. Now, instead of 2 SHM, there could be 3, 4, 5, 6, no matter what. We don't have to go so far. Basically, whenever you are going to get a question, it would be on one particle executing 2 SHMs under action of two different forces or something like that. Now, there are different types of cases that are possible here. There are different types of cases that are possible here. So let us look at the first case, case number 1. In case number 1, it is executing SHM, same direction, and same frequency. That is your first case. It is executing SHM in the same direction and also of the same frequency. So if I call the first SHM as x1 is equal to a1 sine omega t, the second SHM may be like this, a2 sine of omega t plus phi. Now you can see here in this particular case, something is taken as same and something is taken as different. What is taken as same and what is taken as different? You can see this.
Amplitude and phase, sir.
Yes, you can see this omega, the angular frequency is taken as same. But if you talk about this amplitudes and you talk about this total phase of the particle, they are not in the same phase and they are not having the same amplitudes. The two SHMs are not having the same amplitude. They are also not having the same phase. Now, once this happens, the resulting motion, if I find out the resulting motion, the x, the displacement of the resulting motion can be found out by simply adding these two SHMs. And the answer that you will get will be something of this nature. The resulting motion is going to be a SHM, and that is what you must remember. Very important point. When you have a particle executing two SHMs in the same direction, but they have the same frequency, the resulting motion is an SHM. The resulting motion is an SHM. The resulting motion is a SHM. So if the resulting motion is an SHM, it can be written in the form of this. Now there are two unknown quantities here in this equation that you can see. What are the two unknown quantities here in this equation that you can see? The resulting motion is an SHM with the same frequency. Do you see the frequency is same? With the same frequency or angular frequency omega. So the resulting SHM is would be having the same frequency omega. But so we know omega of that SHM, but there are again two more terms which are unknown here. What are the two terms which are unknown here in the resulting SHM? The first term is the amplitude of this SHM, and the next is the value of phi. These are the two things that are unknown in this. How you can find out the value of this? You can straight away write the value of amplitude A as under root of what?
A1 square plus A2 square, sir.
A1 square plus A2 square plus 2 times A1 A2 cos phi. Does this remind you of something that we have already done?
Resultant of two vectors.
This is the resultant of two vectors. So basically these SHMs can be treated as two vectors. We will also see that, but first you write this. This will be the resultant amplitude, but again this phi is also unknown. Can you tell me what will be the value of this phi? No, not phi, xi, this angle xi. How much will this angle xi be? If you understand that this is resultant of two vectors, then you can also tell me the value of this angle xi, and what is the value of this angle xi will be coming as? It will be coming as A2 sine phi upon A1 plus A2 cos phi. I'll give you 2 minutes to write it down, and then I will try to give you more explanation. Note it down, please. Now, we have seen the diagram, and now we'll write the next heading. And what is the next heading? Addition of SHM using phasors. Phasors. Now this term is going to come a lot of time from now onwards till the end of this course. Phasors, and we have already dealt with these phasors before. SHM is a wave, it's a sine wave, and the next chapter is also wave. We are going to deal with waves. Now whenever we have a wave, every wave has a phase, yes or no? That tells us where the particle is. Omega t plus phi in the case of SHM was your phase, yes or no? That tells us where the particle is. So from that word phase have come this concept of phasors. We have also seen that this SHM can be taken as a uniform circular motion, and we can say that the radius of the circle is moving like this. The particle is moving like this. Do we understand this? Do we remember that? That concept can be applied on the phasor as well. So what do? I draw a line like this, and I only draw the amplitude as A1. So I draw the phasor of the first wave. This is known as the phasor of the first wave. This is the phasor of x1 is equal to A1 sine omega t. Do we understand this? If this phasor is here horizontally like this, where is the second phasor? Where is the second wave? The second wave, as you can see, now look at the diagram, look at the equation. The first wave is x1 is equal to A1 sine omega t. I have drawn it like this. Where is the second wave? Is it leading or is it lagging? Remember that term, leading and lagging?
It is leading, sir.
It is leading, so it must be ahead. When I say ahead, it must be ahead of this second wave. First you understand this, then I'll give you time. So if the first wave is here on A1, the second wave would be here somewhere A2. Yes or no? And this angle between the two waves would be phi. Do we understand this? Or it has gone above our head saying bye bye?
Understood, sir.
So now you can see how these waves are actually behaving just like vectors because of the phase difference. Do we see this?
Yes, sir.
Now addition of these two waves is just like the addition of those two vectors. The resultant vector or resultant amplitude will go like this. Do we understand this? A. And it will make some angle psi with this wave. Do we understand this? And therefore you can straight away write what? Straight away write the value of A as under root of A1 square plus A2 square plus 2 times A1 A2 cos phi. Do we understand this? Yes or no?
Yes, sir.
Now, this wave, if I talk about this wave or this amplitude, it will have two components, one along the x-axis and one along the y-axis. Yes or no? The component along the x-axis, this green component, will be A1 plus A2 cos phi. Do we understand this?
Yes, sir.
And it will have a component along y-axis. My diagram is not exactly correct. And that will be equal to A2 sine of phi. Yes or no? And therefore you can get the value of this angle. Tan of this xi is perpendicular divided by base, and therefore you get the answer as A2 sine phi divided by A1 plus A2 cos phi. Do we understand this? How we get this answer? How we get the value of this tan xi? Do we understand this?
Yes.
Yes sir or no sir?
Yes, sir.
We understand how did I get the value of tan xi? Now,
Yes, sir.
what will be the value of this amplitude depends on the angle, right? So I can write if the angle phi is 0, that means both of them are in the same phase. Then the resultant amplitude will be coming as A1 plus A2. Yes or no? Cos phi becomes plus 1. I will get A1 plus A2. If phi is 180 degrees or pi, they are in out of phase or opposite phase. We call them out of phase, exactly opposite of each other. Then your A will become the magnitude of A1 minus A2. If A1 is bigger, it is A1 minus A2. If A2 is bigger, it is A2 minus A1. Do we understand this?
Yes, sir.
So this is how you can add two SHMs like two waves or like two vectors when they have the same angular frequency. But again, this concept can not be applied when they have different what?
Frequencies.
Different angular frequencies, because then the phase difference will not remain constant. Sometime it will increase, sometime it will decrease, and we cannot apply this logic. Do we understand this, or this has gone above our head saying bye bye sir? Going sir. We understand this? Have you noted this
Understood,
down?
sir.
Have you noted this
Yes.
down?
Yes, sir.
Okay. Then I have this question for you. Take your time, solve the answer. Solve the question and get the answer peacefully. Remember, don't take it as a question of simple harmonic motion. This can be a question of waves. Same question. Or a question of wave optics. Same question. Find the amplitude of SHM obtained by combining the two motions. I'll give you 2 minutes to give me the answer. So how are you supposed to do this? You just simply have to put the formula, get the answer and stay happy. A is equal to under root of
PCM ఉందా?
a1 square plus a2 square plus 2 times a1 a2 cos of phi. Both the amplitudes are also same, that is good. Resultant amplitude will be under root of 2 square plus 2 square plus 2 times 2 into 2 cos of 60 degrees. Cos of 60 I think is 1 by 2. So what are you going to get? 2 times root 3. Yes or no? Do we understand this?
Yes, sir.
Everyone got this answer?
Yes, sir.
Great. Then comes this question. Remember, this could be a question of waves. Question number 2. x1 is 3 sine omega t and x2 is 4 cos omega t. Find the amplitude of resultant SHM. Find the equation of the resultant SHM. I'll give you 2 minutes to do this. Remember, you have to do the same thing again and again. Let me proceed and do this. How I'm going to do this? The only problem I see here is one of the equation is in sine and the other equation is in cos. Now, how are we going to tackle this? One equation in sine, other equation in cos. Either convert both into sine or both into cos. I always think that converting into sine is always easier. So I write the first equation as x1 is 3 sine omega t
equals to 4
and
sine
x2 as 4
omega t plus pi by 2
sine omega t plus
pi
pi
by
by 2. So in this case, the phase difference between them is pi by 2.
pi by 2.
Now I can simply find out the amplitude. Amplitude will be equal to under root of 3 square plus 4 square. Yes or no?
Correct.
That is simply equal to 5.
Equals to 4 by 3 pi equals to 53 degrees.
Do we understand this?
Yes, sir.
Then I can also find the value of tan of that xi is a2 sine phi. So a2 is 4 into sine of pi by 2. Sine of pi by 2 is 1 divided by a1 is 3 plus a2 cos of 90, that is 0. So tan phi becomes 4, tan xi becomes 4 by 3, or your xi simply becomes 53 degrees. 90 degrees, I mean, you don't have to even do that. If you understand that if this wave is here 3, this wave would be here 4, you can very easily find out the resultant. The resultant will go like this, and this angle xi, tan of this angle xi will be 4 divided by 3. Yes or no? No, yes.
Yes, sir.
See, it is quite simple this ways. Okay. Can I give you the next one?
Yes, sir.
So here comes the next one. x1 is 5 sine omega t plus 30 degree. x2 is 10 cos omega t. Find the resultant of SHM. I'll give you 2 minutes to solve this. So how are we supposed to do this? We can write, let me do it in a short way. I can write this equation as 10 sine omega t plus 90, just to make 30 and 90. So you can see the phase difference is 60 degrees. So I can straight away write the amplitude as under root of 5 square plus 10 square plus 2 into 5 into 10 into cos of 60 degrees. More often or not, whenever such a question comes, it will be cos of 60 degree only, because it becomes half and it becomes easier to calculate. If it becomes root 3, it will just become too complicated to calculate. Do we understand this?
Yes, sir.
Okay. Then comes, can I move on to the next question?
Yes, sir.
This is the next question that is going to come. Question number 4, I guess. A particle is subjected to two simple harmonic motion in the same direction, having equal amplitudes and equal frequency. If the resultant amplitude is equal to the amplitude of individual motions, find the phase difference between the two. You have to find out the phase difference between the two. I'll give you 2 minutes to give me this answer. So,
Sir, I got cos theta by 2 equals to minus or plus or minus 1 by root 2. So
okay.
that there 5 will be the phase difference.
See, the good thing about solving questions with our own hands is you can get any answer depending on our whims and fantasies. But will that answer be correct? It depends on whether you have done it correctly or not. It is subjected to two simple harmonic motions in the same direction having equal amplitudes and equal frequency. The resultant amplitude is also the same. This is similar to many questions in vectors that you would have done. Two vectors of same amplitude are added and the resultant is also same. What is the angle between the two vectors? Remember any question like this in vectors? Sir, we have not done vectors. Okay, amplitude is A, resultant amplitude is A. That should be equal to under root of A square plus A square plus 2 times A into A cos of phi. Do we understand this? Yes or no? Yes or no? Do we understand this?
Yes, sir.
You can solve this equation and get the value of cos of phi. What is the value of cos of phi you are getting?
Cos of 5 by 2 I got, sir. Cos of 5 by 2 equals to plus or minus 1 by root 2.
Take a deep breath. Should I solve this for you? So I can write this as this: a square is equal to a square plus a square plus 2a square cos of phi. Yes or no?
We can solve it like that. In under root, we can take a square as common.
Yes, you can take it. So, will you get different answers? Anyway, we will come to that. From here, if I solve and find out the value of cos of phi, what will I get? If I solve this, it's such a difficult question to ask. I will get cos phi as minus half. Yes or no?
Yes, sir.
So what is the value of phi? 120 degrees, my dear friend. 120, not 150. So the value of phi, the angle is 150, not
Sir,
150.
once solve inside the root, sir.
Okay. Tell me what to do.
Sir, take a square as common
Okay.
inside the root.
Yes. A square.
And it will be 2 plus 2 cos theta. And a square and a will be cancelled. It will be 2 into 2 cos square theta.
Yes. What are you saying? Correct, no?
Yes, sir. It is 1 plus cos theta equals to 2 cos square theta by 2. And it is coming as 5 by 2 equals to plus or minus under 1 by under root 2. Sir, pi by 5 by 2, sir.
So phi will be coming as 120 degrees. Do we understand this?
Yes, sir.
Do we understand what mistake we are making?
Yes, sir.
Okay. Remember, this is a very famous question. It can come in different ways. Remember, three vectors, if they are equal in magnitude, when will their resultant come 0? When all the three are at an angle of 120 degrees. This is another way in this question can be asked. This vector plus this vector will be equal to negative of the third vector. Do you understand this?
Yes, sir.
Three equal vectors to be in equilibrium, they have to be at an angle of 120 degrees. So A vector, the pink one and the pink one, should be negative of the A vector. You understand this? So the
Yes, sir.
answer has to be 120 degrees. We get this, yes or no?
Yes, sir.
So remember this, do not make the mistake. Everyone noted this down?
Yes, sir.
Okay, next one. Do it fast. This is the next one. A particle is subjected to two simple harmonic motions. X1 is A1 sine omega t, X2 is A2 sine omega t plus pi by 3. Find the displacement at t is equal to 0, maximum speed and maximum acceleration. I'll give you 2 minutes to solve this. Remember, JEE is all about doing things smartly. Now, remember the question they've asked, find the displacement at t is equal to 0. You have to find out the displacement at t is equal to 0. What you have to find out? Say again. Displacement at?
Sir, I have found out displacement equation of resultant SHM.
I don't know what you have found out. I want you to find out the resultant displacement at t is equal to 0. That was the question. Because A1 and A2 are not given. A1 and A2 are given as A1 and A2. There are no values given there. Anyways, the question was to find out the displacement at t is equal to 0. Did you find it out? To find out
Yes,
displacement,
sir.
what is
Find
the
it
answer?
out, sir.
Huh?
Yes, sir.
What is the answer?
Sir, it is, it is the same answer I said before.
Okay. Now see, at t is equal to 0. Now, you remember how did I find out, how did we write the displacement of the resultant waves? You read this. If a particle is executing 2 SHM, then the resultant motion is found by adding the 2 SHM. X is equal to x1 plus x2. We remember this?
Yes, sir.
Pakka na?
Yes, sir.
Okay. At t is equal to 0, what is the value of x1?
A1, sir. Sorry, 0. It
What
is
is
0, sir.
what is the value of x2?
Root 3 A2 by 2.
So what is the value of the displacement? That is the answer, my dear friend. Remember, a question that comes in a JEE is a simple one. And you have to understand the concept to understand the question. Do you understand? It was so simple.
Understood, sir.
And what you have done? Anyways, that was the reason why this question was given. This is as simple. So if time is given, you don't have to go into all those complications. You just can do it uncomplicated way. Yes or no? Now let us move forward and to the next of the question. How would you find the value of Vmax?
V equals to omega under root A square plus X square.
A into omega. So we just put the value.
A omega. एक आंसर है maximum cos
You have to find out the maximum speed as you forgotten the formula of maximum speed.
done.
A into omega. So
Initial
omega is same.
position X equals to
You
0.
just have to find out the resultant amplitude. What is the resultant amplitude? A1 square plus A2 square plus 2 times A1
A2
A2
cos 5
cos
by
60. The cos 60 is half. So your answer will be omega into root over A1 square plus A2 square plus A1 A2. Do we understand this, or this has gone above our head saying bye bye?
Understood, so
How do you find out the value of maximum acceleration? This is A into
A
omega.
omega square.
So you know the value of A, you multiply it by omega square and you get your answer. See, uncomplicated answers.
Sir, how can we find out displacement with using displacement means displacement equation? That is X equals to A sine omega t plus phi. That
When you add these two equations, you get
no,
this.
sir. I'm asking that after finding resultant displacement equation,
You put time as 0 there.
sir, it is coming. What I said.
It's coming what you said. Pakka.
Yes, sir. Yes, and means we cannot simplify that further. So please help us to simplify it further.
But why I need to do this? Because I can do it this way. Why I need to do that? Okay, to get the answer in this way, you'll have to find the value of xi. How do I find the value of xi? I will not be able to. I will have to find the value of psi. It becomes a mathematical problem in itself. You have to apply maths, inverse trigonometry and all those things to get that answer. And that is the reason it gets too complicated in maths. And therefore we use this. This is not a class of maths. Do you understand this? But by
Yes.
understanding this, you can solve some maths ka problem using this concept, not the other way around. We are not learning physics to get jumbled up in maths. We are learning to solve problems in a way where maths may not even think. So whatever you get at t is equal to 0, that is actually equal to a by 2 into root 3 by 2, and that is the problem of your trigonometry in maths. Do you understand this? That is the simplified version of what you are going to get from that complicated variation. Getting my point?
Yes, sir.
That is it. So it will come sine of tan inverse something, right?
Yes, sir.
Then you have to convert that tan inverse into sine inverse, then sine of sine inverse, and then you will get an angle. And that angle that you're going to get is going to come as 60 degrees only. Got it?
Yes, sir.
So, what is better, maths or physics?
Mathematics, sir.
Mathematics. See, your mathematics landed you in trouble. Your physics got you out. Wow. Solve it by mathematics. Even to solve this problem by mathematics, if I give you this problem, how are you going to find out the resultant? How are you going to find out the resultant from this problem? You will have you will have x1 as a function of sine and x2 as a function of sine or something. How will you add this? How will you add these two functions? If you try to do it with maths, you will take 2 or 3 pages to get to the answer. Getting my point? But
Yes, sir.
how you got to the answer quickly? By using a bit of common sense and treating them as vectors. Vector is also maths. But if I try to do it by trigonometry, adding these two sine functions by trigonometry, the only formula you have in trigonometry is sine of a plus sine of b. So you have to reduce it into that form. Do we understand this? So first of all, you have to write a1 in the form of sine or cos, and then you have to multiply two sines and get it in the form of one sine and then other one. At the end of the day, what you will end up with? At the end of the day, you will end up with this. Got my point? So let's not get into complicated maths and let us try to do it by simple logical physics. We get this? We get this or not?
Yes, sir.
Ah. What is better, physics or maths?
Physics, maths.
Chalo then, physics maths. Let's hope that this physics maths combo helps you in getting this question. Now there are 3 SHMs. You have to find the resultant amplitude of this. I'll give you 2 minutes to solve this. And let me go ahead and solve this question. How are we going to solve this question? Remember, I'm going to apply maths, but I'm going to apply maths with physics common sense. And that is what that makes is pretty good. The first phasor I'm going to draw is for 5. And this is the phasor. This is the pink phasor. Do we understand the pink phasor?
Yes, sir.
Then the next phasor that I'm going to draw is the green phasor. The green phasor goes like this. Do we understand this, or this is gone above or it's saying bye bye?
We understood.
How much is this angle for the green phasor? 53 degrees. So far, so good. What about this one? How will I write this blue phasor?
It is, sir, it is 10 sine 3 pi by 2, sir.
10 sine omega t plus 270 degrees. Yes or no?
Yes, sir.
Third phasor comes here. Yes or no? No or yes?
Yes, sir.
You just have to add these 3. How do you add this? By vectors. How do you use vectors? It's a simple addition. This is 5. So I can resolve this into two components. One component will be here. It will be how much? 5 cos 53. And then I will have one more component here. 5 sin 53. Yes or no? How much is cos 53?
4/5.
3 by 5, 3 by 5, 3 by 5, 3 by 5, 3 by 5. So this becomes 5 into 3 by 5. So this becomes 3.
Sir, you asked sin 53, no, sir.
I ask cos 50. Fine. Okay. I take back my words. Sin 53 is 4 by 5. So 5 into 4 by 5. So this becomes 4. Now this is 4 up and 10 downwards. How much will remain? How much will remain here? So I can write it like this. Resultant amplitude ka y component will be how much? Ten is down, 4 is up. How much remains?
6.
6 downwards. Let me just write it as 6. Resultant amplitude ka x component. How much?
8, sir.
See, now you have the answer, sir. Now you have become smart, sir. 6, sir. 5 plus 3, 8, sir. Now I can find resultant amplitude is equal to under root of x square plus y square, and the answer is 10, 10, 10, 10. Do we get this, or this has gone above our head saying bye bye, bye bye, bye bye? See, it was so simple. And I don't know what all formula you were applying here. Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down. That takes us to the second case. Remember, the first case was moving in the same direction with the same frequency. Now they are moving in same direction, and this may come as there will not be any numerical on this, but this will come as a objective question. Same direction but different frequencies. If the frequencies are different, then what happens? So one of the SHM can be written as A1 sine omega 1t. You will not get a question on this. You just have to write it so that if a numeric objective comes, you can answer it in yes or no. So if I add these two, x1 plus x2, now there is no simple way of doing it. It will be a complicated way, complicated maths, and this is a class of physics, not a class of maths. So this will be the resultant motion. What you have to understand is this motion is not SHM, and that is the only thing that we have to understand here. That in this case, whatever we get, this is definitely not an SHM. Do we understand this? So if they are moving in the same direction, even with different frequencies, it will not be an SHM. And if you get a numerical, no, you are not going to get a numerical on this. You will get a objective on this. What happens if they are moving with different angular velocity? Will the motion be SHM? The answer is no, it is not a SHM. Do we understand?
Sir, when do we say the SHM is in same direction? Two SHMs are in same direction.
Sorry?
When do we say two two SHMs are in same direction.
Same direction means it is going, both the SHMs are happening in the positive direction. Or, ma'am, I'm sorry, I don't understand what you are saying.
Sir, means there is any dependence on phase for direction?
There is any, okay, so you are saying one SHM is like this and other SHM is like, if they have the same frequency, not a problem. Phase can be different. Phase was different, na beta?
Okay,
Phase was
sir.
different, na? We gave the answer for out of phase and in phase. Remember, one SHM was happening like this, another SHM was happening same direction means same axis we are talking about.
Yes, sir.
Same axis. If that is what's confusing you, same axis. It can happen that one is moving like this, and the in one SHM it is the motion is like in other SHM it is like this. It's the same direction, same axis. I must say, not the same axis. Okay, but if it is different frequency, I mean, if it is different frequency, doesn't matter. It cannot be an SHM. Do you understand this?
Yes, sir.
Different frequency, it cannot be an SHM. Have you noted it down?
Done, sir.
Case number 3, again, all these cases are, you may not get numericals, but you will get, in this third case, you may also get numerical. Try to understand, and again, our free thing will come. See, perpendicular direction. And this is a special case. Perpendicular direction, but again with same frequency. Because if it is different frequency, then nothing happens. Perpendicular direction, same frequency. Let us say the first SHM which is doing is A1. I'm taking this as different, sine omega t. Then it is also executing SHM along y-axis. A2 sine omega t plus phi. Now, what type of motion it will have depends on the value of phi. What type of motion this is going to have is going to depend on phi. Remember, when the motion was along the same axis, phi does not have much of a saying. It was just the phase difference. But here, one motion is happening here and the other motion is happening here. Do you understand this? Like this. Do you understand this, or this is gonna power saying bye bye?
Yes, sir.
So a lot of things depends on this value of phi. So here we have a sub case. And remember why I'm teaching all this, taking all this in, because I've seen question come from this. You should not be confused. If this question comes, this is straight away +4 or -5. Simple as that. You know it or you don't know it. You cannot just think in the examination hall what is going to happen. So in this case, I will have a sub case. Case number 1. If phi is 0, and again there are many cases possible, but we'll only look at 2 cases. If phi is 0, what happens if phi is 0? What happens if phi is 0? Hmm?
Both will start at the same time.
Hmm? If phi is 0,
Sir, it is an SHM, sir.
what type of motion is that? First of all, tell me that.
That is
If phi is
sinusoid.
0,
It
then
is
your x by a1 is equal to y by a2. Yes or no?
Yes, sir.
Or your y is equal to a2 by a1 times of x. Yes or no?
Yes, sir.
What type of motion is this? This is a
SHM, sir.
straight line motion. This is a motion in a straight line. Yes. Y is equal to mx. It will move in a straight line. Actually, effective motion is a straight line motion. Do we understand this? Yes or no? No or yes? Yes or no? Huh?
Yes, sir.
Motion is a straight line. Now, the motion is a straight line. What will be the resultant displacement of the particle? If I call the resultant displacement of the particle as r, the resultant displacement of the particle will be equal to x
X
square
square
plus
plus
y
Y.
square raised to the power half. Yes or no? Yes or no?
Yes, sir.
So it can be written as a square plus, sorry, a1 square plus a2 square raised to the power of half into sine of omega t. Yes or no?
Yes, sir.
Do we understand this? Now, is this motion a SHM?
Yes, sir.
Yes, that is what you are saying. This is definitely an SHM. Of amplitude, how much is the amplitude of this SHM?
Under root A1 square plus A2 square.
That is what you need to remember. They may ask you this.
Means resultant is SHM. What is this straight line motion, sir?
Yes, straight line SHM motion. So it is having, so basically you see this. One SHM is like this and one SHM is like this, but they are in the same phase. That means they are at the same, I mean, they reach their mean position and extreme positions together. So if you add these two motions, what do you get? You get a motion like this in a straight line. Yes or no?
Means
It is moving.
projection. Their projection,
No,
sir.
not projection. Uh, its projection on x-axis is a SHM. Its projection on y-axis is also SHM, and they
Okay.
are
The
having
resultant.
same
Okay. The
frequency,
resultant is
and they are
straight line
having
motion.
same phase. Do we understand this? So the
Yes, sir. Yeah. Yes, sir.
nice, na? Great, na?
Yes, sir.
See, life is so good. Now two SHM and they add and become again SHM in straight line. That is the beauty of it. And they two SHM are at 90 degrees. Now what happens if the angle is pi? Pi. I mean, if the phase angle is phi. Pi. Then here I get x by a1 is equal to minus of y by a2. Yes or no?
Yes, sir.
Or y becomes minus of a2 by a1. In this case, reverse happens. What do you mean by reverse? If x is positive, y is negative. So it happens in this way. Do we understand this?
Yes, sir.
So again, this is the motion in a,
Straight line.
this is the motion in a straight line. The resultant displacement will be a square plus b square raised to the power half sine of omega t. This is again a SHM.
Sir, B. Where is B?
Oh, sorry. A1 square plus A2 square. This is an SHM. Amplitude is, oh, here also I've written B. Why am I writing B? A1 square plus A2 square under root of A1 square plus A2 square. Do we understand this, or this has gone above and it's saying bye bye?
Both SHMs are same, sir.
They are same, but the only difference is when this is going in the positive direction, this is also going in the positive direction. The slope of the line is different. The slope of the line is different. When x increases, y decreases. Take it this way. When x increases, y increases. That is the one line, line
Yes,
like
sir.
this. Line lying in the first or the third quadrant. This is the line lying in the second or the fourth quadrant. When x increases, y decreases. Nothing else.
Sir, I'm asking about the phase difference between phi equals to 0 and phi equals to pi. What is the phase difference between them?
The phase difference is pi, na? If they are in the same phase, then it is straight line y is equal to mx. If they
Sir,
are in opposite phase, it is a straight line y is equal to minus mx.
sir, let us consider r equals to a1 square plus a2 square whole power 1 by 2 sin omega t as 1 SHM, and r equals to a1 square plus a2 square by, that is second one, when phi's phase difference is pi has 1 SHM.
Yes.
Then what is the phase difference between these two SHMs?
What is the phase difference between?
Sir, 1 minute. I can know. Sir, here we have two SHMs, no, sir.
Yes, here we have two SHMs.
R equals to, in first case 1 SHM, second case 1 SHM.
Right.
What is the phase difference between those two SHMs?
Between these two SHM, what is the phase difference?
Yes, sir.
Between these two phase, if you can say that the phase difference would be, I think, 90 degrees, because if if the first SHM is a positive slope, that means what it means is when x is increasing, y is also increasing, right? Now, what I can say is let me think about it and I'll let you know. I'll have to first imagine it and then I'll let you know. Okay? Let me first think about it and I'll let you know. What you have to understand here is, if this SHM, if in this SHM x is the slope of this line is positive, so when x is increasing, y is increasing. When x is increasing, y is increasing. In the
Sir,
second SHM, when x is increasing, y is decreasing.
Sir, in the second case, what is the phase of sine, sir?
What is the
Is it
phase?
omega t only or omega t plus pi?
That will be omega t only, beta. See, the displace, try to understand. Let me draw the graph here. See, the particle is executing SHM in x-axis as well as y-axis. Okay? Do you understand this? Now, the resultant SHM in first case is going to come like this. It's going to come like this. It will execute SHM like this. Up, down, up, down. So basically, it is going to, this SHM is going to happen if I track quadrant wise. This SHM is going to happen in the first and the third quadrant. If the mean position is here, that this SHM is going to happen in the first and the third quadrant. Do we understand this?
Yes, sir.
The second SHM, if I talk and if I just draw it by the blue line, the second SHM happens here like this. It happens here like this.
Sir, so that there is some difference between these two SHMs, red and blue.
Red and blue, there is
But equations are same. How, sir?
Equations are same, beta, because see, if you turn this by 90 degrees, now if you turn this, see, equation are same. What you have to understand is it is giving you the value of r from the mean position. It is giving you the value of r from the mean position. This SHM is the blue SHM is going to give you the position of r along this line, and the upper wala will give you r along this line. R along
Okay,
this
sir.
line. See, are you getting my point? It is the r. The equation is same. The equation does not depend on which axis it is going, which axis the SHM is happening. You can see the two equations that we had were like this. The two equation we had was like this, right? It does not depend on which axis that SHM was happening, right?
Yes, sir.
Wrote it as x and y, the x coordinate and the y coordinate, nothing else we did. Similarly, these two SHMs are happening along different lines. They are not x and y axis. Are you getting my point?
Yes, sir.
The only thing is, it is not happening along x and y axis. It is happening at a line which is inclined at an angle. And you can also find that angle because the phase difference is constant. You can find out angle tan theta will be a2 by a1. Yes or no? Because the slope
Yes,
of the
sir.
line is known to you. So you know the slope of the line. You know the slope of this line, b by a, tan inverse b by a. And the SHM happens along this line. What is the problem? You just don't take it as axis. This is just a straight line motion now. Straight line SHM. Dung, 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 dung. This straight line motion is happening because of two separate SHMs happening on x and y axis. So as you said, this is something like the projection of SHM as UCM. It is happening on x axis also. It is happening on y axis also. But because of that, because of these two having phase difference 0 or pi by 2, it is happening in a straight line. We get this?
Yes, sir.
Or have I complicated it further? Do you understand this, everyone? Whether the SHM is happening on x axis or whether the SHM is happening on y axis, it just happens in that axis. The equation, whether it's on x axis or whether it's on y axis or whether it's on any axis, the equation of SHM remains same. It only gives you the position of the particle from the mean position along whatever axis the SHM is happening. Am I clear? Yes or no? It has gone above or it's saying bye bye.
Yes, sir. Understood, sir.
Pakka na sir? Pakka?
Yes, sir.
Not pakka. Then comes the last case, subsection B. Subsection C, sorry. If phi, the phase angle is pi by 2. Now, that makes things more interesting. Now, when the phase difference is 0 or 180, it is a straight line motion. Straight line SHM, not motion. Straight line SHM. If the phase difference is pi by 2, then what happens? Your x wala equation becomes a1 sine omega t, and the equation along y axis becomes b1 cos omega t. Do we understand this? Now, why I'm writing b1? a2 cos omega t. Do we understand this?
Yes, sir.
Then what is the resultant motion? Resultant motion x square by a1 square plus y square by a2 square is equal to 1. Do we understand this? Yes or no?
Yes, sir.
This becomes the equation of a
Ellipse.
our favorite ellipse. See, this is the equation of an ellipse. So the motion is in elliptical path. So Elliptical path is also a SHM projection. Projection on x-axis is SHM, projection on y-axis is also SHM. Do we understand this, or this has gone above our head saying bye bye?
We understood.
Pakka? Now,
Yes.
another special case happens when A1 becomes equal to A2. Then what happens? X square plus y square, let me call it as A, becomes A square, and this becomes our equation of a circle. And SHM as a projection of UCM, so circle comes back. Do we understand this, or this has gone above our head saying bye bye?
We understood.
Okay. Now the next question is the resultant motion SHM? No, the resultant motion is not SHM. Why it is not SHM? If I find the resultant amplitude, it will be resultant displacement. It will be A1 sine omega t plus A2 cos omega. A1 sine omega t whole square plus A2 sine omega t whole square ka root and all those things. Do you understand this? It becomes a very complicated motion. It will not be an SHM. So the resultant motion is not SHM. Do we understand what we have done here in today's class? Do you understand this, or this has gone above our heads? So what we have seen here, I will
I
just
didn't
go.
get it.
Yes?
I did not understand, sir.
What you did not understand?
Last point.
It is not going to be an SHM because you will not get it as a sine wave. It will be sine square wave ka sine square plus cos square wave ka root. It will not be a sine wave. So it's not SHM. Okay, you cannot represent it as a sine wave. You understand now? Because the resultant amplitude, the resultant displacement is A1 square sine square omega t plus A2 square cos square omega t. Got this?
Yes, sir.
Okay. So we have seen superposition of SHM and we have done a lot of things. The majority of question will come if it comes from this, where they are in the same direction with the same frequency, the motion is simple harmonic. If they are in the same direction but the frequencies are different, then the motion does not remain simple harmonic. Do we understand this?
Yes, sir.
And we have seen if they are in perpendicular direction with the same frequency, then the motion is a straight line, and the straight line is also SHM. Do we understand this?
Yes, sir.
Then what we have seen is if it is in same direction, perpendicular direction, phase difference as 90 degrees, then it becomes either the equation of an ellipse or a circle. The resultant motion is not SHM. These questions are going to come only in JEE Advanced, not in JEE Mains. So keep in mind that fact. In the next class, we are going to wind off this chapter once and forever, but these waves are not going to leave us alone because waves are coming. Up till now, there was a sine wave, and now a more typical sine wave is coming. So, welcome, waves, and we will try to wind up this waves as quickly as possible so that in the next year, I have to complete thermodynamics as well. I'm thinking of completing thermodynamics also before moving on to electro. So, let's see how things pan up. I'll see you in the next class. Take care. God bless all of you.
Sir, what is next